So what is the extreme value theorem? Well, we just saw some examples of it. If f of x is continuous, that means when we draw the function, remember functions pass vertical line test. When we draw the function, we don't have to pick up our pencils. That means no holes, no vertical asymptote. If f of x is continuous on a closed interval ab, that means include left endpoint a, that's an x value, and include right hand endpoint b, that's an x value as well. From x minimum to x maximum, that's that horizontal value. If those two conditions are met, then the function has both a maximum and a minimum on the interval. Notice we have to have a closed interval, and that implies that we have to check out both x equals a and x equals b, the two endpoints, to see if our absolute maximums and absolute minimums fall at the endpoints. So what are the absolute or global maximum and what are the absolute or global minimums? Here's the definition. An absolute or global max is the maximum value of a function on an interval. Value of a function. You have to, when you see this value of a function, you have to understand that they're talking about the y value. Where it occurs is the x value, but the highest y will be the absolute maximum of a function on an interval, and the absolute or global minimum value of a function on an interval will be the minimum value of the function. Again, we see this value of the function, and we have to be able to read, they're talking about the y coordinate, the lowest y coordinate on an interval. Where that occurs is the x value. But what is that value? That's the function value, the y value. Can we come up with a recipe to find the absolute extrema on a closed interval? Certainly we can. Number one, find the critical values of f of x in AB. Know this, that's the open interval. Don't include the endpoint A, don't include the endpoint B. So what are we going to do? We're going to set our derivative equal to 0 and solve. And we're also going to find where our derivative does not exist. That's probably the most important step. Set your derivative equal to 0 and find out where your derivative does not exist. Once you find those critical x values, plug those x's into your original f of x or y equation to find the y value for each x in this open interval AB. So in the middle of the graph, you find your highest and lowest x and y, y values. Now, look at the endpoints. Evaluate f of x for both f of a and f of b. So you've got the x and y values in the middle of the graph that are your relative or potentially your absolute mins and max. And you're also looking at the endpoints. Now, once you've got all those points, these are x, y points. And again, if you want the y value, go back to the original equation in both step 2 and 3. Once you've got all those points, the largest y value, identify it, that's your absolute max. The smallest or the lowest y value, identify it, that's your absolute minimum. That's all you have to do. Set derivative equals 0, find where the derivative does not exist. Once you get those x values, plug them in, find the y values. You go back to your original function to find the y values, and then find the y values at the endpoints. Highest y value, that's your max. Lowest y value, that's your min. That's it. It's not that complicated. Before we do an example, I just wanted to talk to you about how continuity, remember, if a function is continuous, we can draw it without picking up our writing utensil. Continuity can affect extrema on an interval. So here, I've got a continuous function on a closed interval. Why do I say closed? Well, look, I've got these points here when x is equal to a and x is equal to b. I can include both x equals a and x equals b. Here is our max, and this point here is our minimum point. So very straightforward on a closed interval with a continuous function. Highest y value is the absolute max. Lowest y value is absolute min. Now look what I've done. I've changed the interval from the closed interval to the open interval. So I have an open circle here and an open circle here. So now this remains our minimum point, but this is not a maximum. And that's what I have to say. Look, it's not a maximum because we have an open circle there. There's no point there. Here, I've changed the interval back to being a closed interval, but now this is a hole. So we have to say this is not the minimum value because we have no value there. There's no XY value there because we have an open circle. It's a hole. You can see when we have a hole, we affect continuity, and that affects our maxes and mins. Since I changed this back to the closed interval, this is returning to our max value there.